In this video, we're going to look at the idea of proportionality in the context of a square whose size can vary. So I have a square here, and I can vary the size of this square. Let's start by considering how the perimeter of the square is related to the side length of the square. So as the size of the square varies, both of those quantities are going to vary. And if we posit at some moment, like this one, then the perimeter is 7.2 centimeters long, and the side length is 1.8 centimeters long. So if we were to measure that perimeter length, 7.2, in units of the side length, which is 1.8, that measurement would be 4. 7.2 divided by 1.8 is 4. Now, if we continue varying the size of this square, and then we posit at some other moment, then at this moment, the perimeter, the measure of the perimeter, in units of the side length of the square, which is 11.6 divided by 2.9, that also has a value of 4. It turns out that no matter what the size of the square is, the measure of the perimeter in units of the side length of the square is always 4. And therefore, the perimeter in centimeters is always 4 times as large as the side length of the square in centimeters. In this case, since we have this constant measurement, we say that the perimeter and the side length of the square are proportional. Now, let's coordinate the area of the square in square centimeters and the side length of the square in centimeters. So as the size of the square varies, both of those quantities are going to vary. So at some moment, the size of the square, the side length of the square is 3.2 centimeters, and the area is 10.24 centimeters squared. And at this moment, the measure of the area in square centimeters, which is 10.24, in units of the side length of the square in centimeters, which is 3.2, that measurement is 3.2. Now, if we let this square get a little larger, we posit at some other moment, then at this moment, the measure of the area, 15.21 centimeters squared, in units of the side length in centimeters, which is 3.9, that measurement is equal to 3.9. And if we picked another moment, then the measurement of the area in units of the side length, again, is going to be different. And it turns out that as the size of the square varies, the measure of the area in square centimeters in units of the side length in centimeters varies. It is not a constant measurement. And therefore, the area is not proportional to the side length of the square. In general, we say that two quantities are proportional if the measure of one quantity's value in units of the other's value is constant as the two quantities vary together. And this entails that the two quantities are proportional if the value of one quantity is always the same number of times as large as the value of the other quantity. And so if x and y represent the varying values of two quantities that are proportional, then y will be some constant number of times as large as x. So y will be equal to c times x for some constant number c.